So first of all, guys, before starting our lessons, we need to know what our lesson is. So uh, let you know our lesson is what is our lesson? Lesson is effect of heat. Effect of heat on matter. So this is our lesson we'll be working on. So let's start it. So let us assume we got a box here, and inside the box we got several little dots intertwined, very closely related to each other, very close. It's so close that we cannot see. Yes, this close. Every dot is very close. So let's see. So what do you call it? State. We call this state solid state. Call this state solid state. Now let us apply some heat in this solid stage. So red, I think red is the color for heat giving, I guess. I can't find the red. So we give heat delta H. So we give it heat. So what will be the next thing that occurs after giving heat? Let's say 2 minutes later. Let's not say 2 minutes later, let's say it's a minute later. We see that the particles are spreading apart. The particles are spreading apart like this. They are not closely intertwined anymore. They're far apart from each other now. Yes. It would take a while to illustrate this, and I'm gonna say something as I fill out this. Yes, I haven't actually brought this concept app. I'm a very broke guy, you know, just like Michael Scott's paper company, but I'll still earn from it by using my techniques. You know what I'm saying? Yes. So how do or why do they go apart as we apply heat? Okay, so suppose that you're in a room with 3 people. Yes, you are in a room with 3 people. You are the temperature of the room, as we guessed. The temperature of the room is, suppose it's what, 25 degrees Celsius. It's very moderate. So you guys are at a moderate timing, moderate distance. But if I decrease the heat, you guys are now freezing. So what would you do? To get the body heat, you guys would come close to each other. Yes. And what will happen if we increase the heat? If we increase the heat, you feel hot. So you guys will go apart from each other. So this latter subject happened in this case. We increase the heat, so they are feeling hot and they're getting away from each other. So This state is called the liquid stage. One step is liquid. Suppose that is ice and this is distant water to water. The next step will also be applying heat. So we apply heat, more heat. Then we will see at some point the particles will move more apart. Apart-test, as I would say. Don't take that seriously, okay? Dope. So yeah, that's about it. Now they're moving very far, only a few particles left. They moved so far. So this state is known as the gaseous state, and in terms we could call it water vapor. Yes, water vapor. So we don't give heat anymore, but we could. But let us first see a graph of this heat giving. So assume it's a graph. Okay, it's a graph. Oh, there is a dot point here, so we could use that. Okay. This is temperature, temp, and we could say this is time. And in time, we got 1 minute, 2 minutes, 3 minutes, 4, 5, 6 minutes. Temperature we got -4 degrees, 0 degree, 10 degrees, dot. Let's say 100 degrees Celsius. Now let us see the movement of the particles. So we increase the heat. Oh wow, nothing. Damn, that's good. Okay, so we increase the heat. It's increasing. Now 0 degree, that ice will not any longer take heat. The heat will no longer increase at some point. After it has reached 0 degree, become constant for a while. We'll observe this. Then at the second point we're moving, and at 100 degrees, let's say 100 degrees there, it will stay constant again. So constant again. So what occurred in these stages? Let's mark these stages as this color stage, then a specific constant stage. Let's give it this color, and this color state, and a specific let's say green color state. And it again goes up, so this state again. Okay, so what's happened in these colors? So let's see what happened in these colors. So in terms of this color, here, the ice, it was ice there, it was whole ice. And at this point here, it's called latent heat. What do you call it? Latent heat. Now at 0 degree, ice breaks into water. So to break the molecules of ice, they're very closely bonded. To break it into a far away bonds, some heat is needed for them, right? So they can move farther away, just like I gave the example of a room with some people. So in this case, the temperature that we're giving is being used by ice to turn it into water, to turn all the ice molecules into water. That's the latent heat of solid, we can say, or the latent heat of fusion, we can say, fusion. Then this stage, what occurred in this stage, so all of it was water. Its temperature is increasing. Then the water temperature reaches 100 degrees. Now what happens? Now this is, again, we have reached a latent heat, and this time is the latent heat of vaporization. What is that? F equal to fission, V vaporization. What do you mean by that? That means that look here, so the particles of water is here far apart, but there are lots of them, not that far apart. We have to make them into what? Make into vapor. So vapor, that means gaseous state, so that should be too much far apart. So to transfer this from this, we need some energy, right? Or we need some heat. So that's why all the heat that was supposed to up is being constant, because it has been used for turning that water into vapor. So it's the latent heat. Then this state, say, or vapor.
Don't come outside.
Okay, now it's chill. So we can say that all is vapor. Yeah, right. So this is the state we are telling you about. So that is why this graph will be easy to understand for you, of heating some things, the effect of heat on matter. So we'll move on to next topic, shall we? So in the next lesson I will talk to you about what will I talk to you about? I don't know. Guess I'll talk to you about some basic temperature things, such as Kelvin, Celsius, Fahrenheit. I will talk to you about the relation between that. So in the next lesson will be Celsius, Kelvin, and Fahrenheit and their relation. So stay tuned, everybody. I hope you will like it very much. Till then, oh, that's a love, that's not a but, that's a love. Okay, Oh shit. Okay, no problem. Oh no. Okay, never mind. Wait. Oh, mate. Don't make it worse. Okay, goodbye, guys. See you in the next lesson. Turn it off.